All right, so this should be part two to our acceleration notes. I think when we left, you guys had a couple of practice problems, so I'm just going to quickly go through those just so you can see the math, and then also talk about how we might be graphing these types of changes in motion. All right, so we're going to use this equation, the acceleration equation, which recall is just a change in velocity over time. So if we have a car speeding up from 5 meters per second to 15 meters per second in a time of 2 seconds, we can calculate the acceleration by just putting in the following information, right? The final velocity, or v2, was 15 meters per second, whereas the initial velocity, vi or v1, was 5 meters per second. And of course, the time that it took was 2 seconds. So just being very careful about looking where our units are and keeping track of that information. So then we just have to plug and chug. So V2 minus V1, 15 minus 5, well, that's 10 meters per second, all over the time, which is 2 seconds. Okay, and then 10 over 2 is 5. And then we're going to carry over our units. So that's going to be 5 meters per second per second. So meters per second per second. You could also write this as 5 meters per second squared. That's what happens when you divide the variable by itself in the denominator. So you can simplify it like that, but these both mean the same thing. So really what this is saying is that our car is accelerating at a rate of 5 meters per second every single second, right? So every second, its speed is going up by 5 meters per second, its little speedometer. Right? The next thing we want to do is sketch a velocity time graph of the car, and then talk about how is the acceleration related to the graph. Okay? So a velocity time graph should look like this. We're going to have time on the x-axis and then velocity on the y. And without putting in any real numbers, I know that we're going up by 5 meters per second every second. So let's just say this is 5, and that's 10, and that's 15. Okay, we got 1 second, 2 second, 3 seconds. Okay, so at the start, we're going 5 meters per second. So at time of 0, we're at 5 meters per second. And then 2 seconds later, 1, 2, we're at 15 meters per second. Okay, so we're going to have a nice straight line like this. Okay, now acceleration related to the graph. If you remember when we were looking at distance time graphs, we said that the slope is equal to the speed, right? The steeper the slope, the faster it's going. Well, in a velocity time graph, the slope is equal to acceleration. Okay, so slope is equal to the acceleration. So remember that slope is rise over run. Well, our rise is velocity, our run is time. So meters per second over seconds, those are the units for acceleration. So when you're looking at a velocity time graph, the slope is equal to the acceleration. Okay, so just something to kind of keep in mind.